2.2, number 100. We've got volume of a box. An open box is to be made from a square piece of cardboard with dimensions of 1/3 by 30 inches. Alright, so there's our box. They tell us, they actually show that the corners are cut off. So if this whole thing is 30, and this whole thing was 30, and we chop off the corners and fold it along these green lines, you can see that it's going to form a box that this is the bottom of it. It's now 30 minus 2x. So 30 minus x minus x. Same thing is true for this one. This is 30 minus 2x, and then the height of our box is this distance right here, which is just x. So our volume is x times 30 minus 2x times 30 minus 2x, so x times 30 minus 2x squared. Alright, so what are we supposed to do here? Express the volume V of the box as a function of x. So we just did that. They want us to expand it probably, so V equals x. This is 30 minus 2x times 30 minus 2x, so that's 900 minus 60x minus 60x plus 4x squared. So the book answer, oh, and then we still have an x times that stuff. So it's V of x, the volume is 4x cubed minus 120x plus 900. Alright, so state the domain, that was part A. State the domain of V, the volume. Okay, so the volume, well, we know we could actually state the domain of V. Okay, so possible x values of our function V. Well, the smallest it could be is 0. Like this could be 0. And we wouldn't include 0, but you know, x could be really, really small. This distance could be really, really small, all the way down to 0, not including it. So our domain would be x greater than 0. We don't include it. And the biggest it could be, if I chop this right in half, is 15. Now it can't be 15 because then you wouldn't even have a box. But if this was x and that was x, 15 would be the biggest it could be, and we're not going to include it. So we'll say from 0 to 15 would be our domain. Interval notation would be 0, 15 parentheses.